Today, our team, Francesca, Sydney, and myself, Enzi, would like to present a review of Segetis Incorporated. Segetis is a technology-enabled green chemistry company whose primary goal concerns the production of levulinic acid from cellulose. Levulinic acid and its derivatives form key building blocks in the production of many polymers and organic solvents, giving it recognition as a top value-added chemical by the Department of Energy. Despite its benefits, however, engineers face many challenges in the levulinic acid production process due to high temperature requirements and low yields, which ultimately factor into a high cost. We list some of Segetis' main competitors here who have also tried to improve this procedure, but through the rest of the presentation, we will focus on a novel process patented by Segetis for the production of levulinic acid. As a brief outline of the process, it begins with acid-catalyzed hydrolysis of sugars obtained from cellulose in biomass. This produces char as waste, which is filtered off, and the remaining mixture of levulinic acid and formic acid is separated, distilled, and crystallized to isolate the levulinic acid.
To look at the aforementioned processes in more detail, we can refer to our process flow diagram. For this diagram, we will use the abbreviation shown at the key below. The first unit operation shows a reactor in which two reactions take place. First, cellulose with a sulfuric acid catalyst is dehydrated to form an intermediate, HMF. This is then rehydrated to form the product LVA, FA, and char. After the solution goes through a series of temperature changes, it is filtered to remove char. In the following storage vessel, a water-immiscible solvent is then added so a separation can take place between two layers of liquid. The solution containing LVA and FA then undergoes a distillation to extract the solvent, before finally undergoing crystallization, which gives us the final LVA product. Segetis' process also makes use of a recycle stream after the separation. After undergoing some heating, the solution with useful sugars is streamed back into the reactor where the process begins again.
Only one unit operation of this process involves an actual reaction, and it is here that we turn our attention, as this is the signature unit operation that makes Segetis special. Biomass and highly concentrated acid are added to the reactor, the former of which reduces cost of raw materials, and the latter acts as a catalyst that increases yield and purity of the HMF. This is important because HMF is the intermediate that gets hydrated to form levulinic acid and other waste products that eventually get separated down the line. The acid is added at the beginning and used up, making it the batch component. The organic matter is streamed in until it reaches steady state, making it continuous and the overall process semi-continuous. The operation is run at the relatively low temperature of between 60 and 110 degrees Celsius, which is possible because of the acid's catalytic abilities. The residence time is between 30 minutes and 1 hour.
In summary, Segetis' process represents an improvement over the standard technique to produce levulinic acid, making it a viable, greener alternative in the production of polymers.
What makes Segetis' process so innovative is that it uses common biomass as its main reagent, catalyzing it with acid, thus producing high yields of the intermediate, called HMF, and ultimately of the levulinic acid itself.
Though Segetis has multiple patents issued, currently, the company has not yet produced levulinic acid on a commercial scale. It is still undergoing test production in a pilot plant in Minnesota. However, with new technologies like the ones highlighted in this video, Segetis is on track to creating an environmentally friendly process that optimizes the production of a very important chemical to society.